Hello dear students. Welcome to the Gradeup. Come on dear students, join the session. Am I audible and visible dear? Am I audible and visible dear all? Amandeep, good evening dear. Yes, Kaljan, Kaizen, very good evening. Aman, very good evening. So, dear students, am I audible and visible? Am I audible and visible to you guys? Very nice, very nice. Okay. So, in the today's session, dear students, we will be looking for the numericals based upon the non-traditional machining process or the computer integrated manufacturing systems. So based on that we will be having the today's session. Come on, join the session very fast. Join the session very fast. Be the part of the session dear students, and very welcome to the Gradeup, the India's largest e-learning platform. This is about me. I am Onkar, having more than 10 years of experience for teaching GATE and ESE. Till now I have mentored more than 10,000 number of students. My area of expertise are production and industrial engineering, fluid mechanics, mechatronics, robotics as well. So dear students, so till now in this crash course dear students, we have completed since from starting. We started with the casting technology, then we had the session on the welding technology, metal forming, sheet metal working, metal cutting. Also we had the 2 sessions. And dear students, this is the time now we will be looking for these 2 chapters togetherly, that is the non-traditional machining and the computer integrated manufacturing systems, that is advanced machining methods, right? So shall we start? Shall we begin? So please come on, join the session and be there till last, and have the calculators with you so that you can do the calculation. Be interactive in the chat box. Make this chat box live. Akhilesh, Rahul. So I hope Aman, all are there for making this calculations and keep the chat box live. So shall we begin? Shall we begin? So dear students, when you talk about this non-traditional machining methods, of course in the GATE examination you will find the very important area from that is the ECM and the EDM process. So there are a lot of chances to have the numerical for 2 marks from these particular these subtopics, that is electrochemical machining and the electro discharge machining. Otherwise rest of the things, many times they will ask the question based on the match the pairs, some application of the processes or some important parameter, particularly about say USM, HM, some of the things, important things regarding to that they can have the questions. But whenever numerical definitely come dear students, it will be on the ECM or EDM, but most of the times you will find it is on the electrochemical machine, isn't it? So the same thing we are going to discuss today about the numericals, right? So shall we begin? Akhilesh, Rahul, Sanjay. So take the first thing or first numerical we'll start with. So in a electrochemical machining process with the pure iron workpiece, a removal rate of 8 centimeter cube per minute is desired. Determine the current required. So we'll start with very simple numerical. So please start solving the question, dear students. See what is given. An electrochemical machining process with the pure iron workpiece, a removal rate. So material removal rate is given, that is 8 centimeter cube per minute. Okay, and please dear students, keep this one thing in the mind whenever you solve the numericals. Okay, on the ECM generally you try to keep all the units in the CGS system. Okay, so where the weight in the grams, so the length in the centimeter and time in seconds, right? So if you keep like this, definitely you will be getting all the things at place, right? At place. So try to use the CGS. Okay, no any issue if you use the other one also. SI also it is no issue, but generally if you take the unit system CGS, it will definitely help you because formula like this. So come on dear student, join this session very fast. Join this session, we are going to solve the questions here. So see, it is given in 8 centimeter cube minute. So definitely I want this MRRQ in terms of say centimeter cube per second. So definitely how it will be 8 divided by 60 because 1 minute having 60 seconds. So that is my Q here. And you know dear students, if you look at the MRR in the electrochemical machining, it is given as Q is equal to A into I divided by rho Fz. Whenever your anode is having the pure material, right? That is workpiece material is a pure. It is not made up of any alloy. So it will be in centimeter cube per second, right? And dear students, many times they will also ask the M dot. The mass flow rate they will ask, which is given as AI divided by Fz, which is in grams per second. This is the mass flow rate and this is the material removal rate, dear students. So here in the question what they are asking about the mass, not the mass flow rate, they are asking about the material removal rate, right? And how much it is. So valency is given to gram atomic weight. A is what? Gram atomic weight. I will write here. So A is what? Gram atomic weight. Right? I is the current in amperes. Current in amperes divided by F. F is what? Faraday's constant 96500. Okay, coulombs per mole 96500, that is Faraday's constant. And rho is the what? Density of material, anode material you can say, that is say in grams per cc. So all the units I have arranged in terms of the CGS. Right, now you can simply put here Q is equal to what? AI divided by rho Fz. So Q is how much? 8 centimeter cube per minute. So 8 centimeter cube per second divided by 60. 8 by 60 is equal to A into I divided by what is the density? It is 7.8 grams per cc. It is 7.8 into Faraday's constant 96500 into Z valence is how much? 2. So calculate the current. Please be the part of these calculations and tell me the answer. So I is nothing but you are getting 3584 ampere. Yes, that is absolutely correct, Akhilesh. Very nice, Akhilesh. Vivekanand, very good here. Very good, very good. 3584. Very nice, ampere. 3584. Please, dear students, ask your friends to join this session. Yes, come on. Yes, 3584 ampere, that will be the current. Yes, to achieve the MRR of this 8 centimeter cube per minute. Right? I hope it is clear. Amandeep, Kaizen, Lucky Movies, please. Sanjay, do the calculation. Participate. Next question. So dear students, when this formula, when it is used, when the workpiece material is made up of the pure material, say when it is made up of the alloy. So for the alloy, dear, what we are going to do? So for that, some alloy contain having some different compositions. So different elements are there. So based on that, we will first calculate the density of that alloy. Okay. So density rho is calculated. Okay, it is equal to 100 divided by summation of xi divided by rho I. This is I from 1 to n. So how many composition elements are there in that particular material in alloy? So x is what? Percentage by weight percentage of that particular element in the alloy, weight percentage in the alloy. Okay, and rho I is what? The density of that particular element in that composition, density of element. Of course, you take in grams per cc. Right? So first of all, what? Whenever the alloy is there, when your workpiece is made up of alloy, then we need to find out the density first. Then we will get this material removal rate in terms of Q is equal to 0.1035 into 10 to the power minus 2 divided by this density, calculated density rho for that particular alloy, into 1 divided by summation of say I ranging from say 1 to n. N is how many elements are there in that particular alloy, right? Which is into this xi zi divided by ai. So where xi, you know, xi is the weight percentage of that particular element. Zi is what? The valency of that element, okay, and ai is what? The gram atomic weight of that element. Okay, whenever there is, instead of pure material, alloy is there, gram atomic weight of element. So please remember, dear students, so whenever they will provide you certain alloy or compositions, okay, so in that case you need to calculate the density first. If density is given directly, no any issue, but you have to go for calculation of this xi into zi divided by ai. So how many number of elements are there in that particular alloy? So go on calculation for that, and you will get this Q in terms of centimeter cube per ampere second. Centimeter cube per ampere per second. This is the material removal rate you are getting in terms of this. So definitely when you multiply this thing, okay, actually you multiply this thing, say if say this is the Q dash, if I say, then our required material removal rate Q is equal to this Q dash into multiply by current. Okay, then definitely the centimeter cube ampere second is there. If you multiply by current ampere, you will get the material removal rate, required material removal rate Q in terms of centimeter cube per second. So this is very important. So this is a very basic thing for our next question, right? So chalo lete iske upar ek question. Let us see how they are asking the question on this. So I am taking here a very big question, so that any number of elements are there in that particular alloy, you can able to calculate that. So let us see the question. So see the question in front of you, dear. See the composition of the mnemonic alloy, that mnemonic 75 alloy is as given here. Okay, calculate the removal rate in centimeter cube per minute. See, they are asking centimeter cube per minute when a current of 1500 ampere is passed. use the lowest valency of the diffusion for each element. This is already given to you. Say this mnemonic alloy, this mnemonic 75 alloy is consist of how many elements? Say there is a nickel is there, chromium is there, iron is there, titanium is there, silicon is there, manganese is there, copper is there, and for every material the percentage weight composition is here. That is, it is 72.5% of nickel is there, 19.5% of chromium is there. This is all in percentage, weight percentage of that particular element in that composition. Okay, and all the properties are given here. Okay, you are given with this all the things where the gram atomic weight A is given, valency Z is given, and density rho is given to you. Now using this data, dear students, using this data you are going to calculate the material removal rate in terms of centimeter cube per minute for this particular mnemonic 75 alloy. Okay, so shall we start for calculation of this? Shall we begin for calculating this thing? So what is the first thing that you have to calculate first? So we need to calculate first the density of this particular mnemonic 75 alloy. Okay, because there are n number of elements are there. There is no any pure only one thing is there, but it is alloy. Definitely I need to calculate the density of this alloy, which is given as 100 divided by summation of xi divided by rho I. So how many elements are there? 1 2 3 4 5 6 7. So I is equal to 7. Okay, please calculate the density and tell me what is the value for the density. So I will write this rho is equal to, say, summation of, say, 100 divided by summation I is equal to 1 to 7, that is xi divided by rho I. So what I will do, I will calculate first this summation of xi divided by rho I. Okay, xi divided by rho I, so that is, it is starting from the nickel, it will starting from the nickel up to the copper. So just go on calculation of this density or this xi divided by rho I ratio. So starting from the nickel, it is, what is percentage? Gram weight percentage of nickel 72.5 divided by what is the density of nickel? It is 8.9 plus then which is there? Chromium is there. So percentage of chromium is how much? It is 19.5. So I will write here, see, like this only, divided by what is density of that chromium? 17.19 plus then there is iron. How much percent is there? Iron 5%. 5 divided by density of iron 7.86 given, 7.86. Like that, if you write all the things, 0.4 divided by 4.51 plus 1.0 divided by 2.33 plus 1.0 divided by 7.43 plus 0.6 divided by 8.18. So see, starting from nickel up to the copper, I have written all the things. Say for copper, what I can write, the weight percentage is 0.6 and the density is 8.96. So see here, 0.6 divided by 8. For copper it is 96. 8.96. Okay, so all things are clear. Okay, now tell me what is the value of this summation xi divided by rho I. Please calculate, dear students. Don't sit only. Please take a part in the calculation, because see, these are the very lengthy things we have to see. You will say, sir, will they ask such a long composition in the examination? No need, dear students. They may be given you only 2 to 3 elements. For that only they will ask, or to make the things easy, instead of calculation of this density, they will give you the value of directly the density of that particular alloy, and after that you can go for calculation of the rest of things, right? So if you calculate, so is it 24.473? Check it out. So I hope when you put the values, all the things you calculate, and you write here 100 divided by summation I ranging from 1 to 7 xi divided by rho I, you will get the density as 8.18 grams per cc. So for this particular alloy, you will get density as 8.18 grams per cc. Please check it out. Yes, that is correct. Kishore, that is correct. So all the things you are getting here, this is equal to 12.213. Okay, and 100 divided by this, 100 divided by 12.213, you will be getting 8.18. Yes, please dear students, Vivekanand, Akhilesh, Sanjay, what is the answer? Yes, 8.18 grams per cc. Right? Now once you get this value, what is to be done next? What is to be done next? So now you know very well this Q, the removal rate in terms of the centimeter cube per ampere per second, which is nothing but 0.1035 into 10 to the power minus 2 divided by this density that we have calculated just now into 1 upon summation I ranging from say 1 to 7 here xi zi divided by ai. Now density is known to you. Now you don't know these things, so go and have a calculation for these things. So xi zi divided by ai, how we will calculate? So start from the first alloy, that is nickel. How much it is? Nickel percentage 72.5 into what is valency of nickel? 2 is given, divided by gram atomic weight of the nickel, it is 58.71. Like this up to copper. From nickel, we will start from nickel, we will go up to copper, and we will find this xi zi divided by ai. Calculate. Aman, very good Aman. So Akhilesh, very nice Akhilesh. So tell me, that is say 19.5 into 2 divided by 51.99 plus 5 into 2 divided by 55.85. This is for iron, plus 0.4 into 3 divided by 47.9 plus 1 into 4 divided by 28.09 plus 1 into 2 divided by 54.94 plus 0.6 last, this is copper, into valency 1 divided by 63.57, that is the gram atomic weight of the copper. From nickel, this is say iron and this is copper. Like that we go on through calculation of this xi zi divided by ai. Tell me what is the value of this xi zi divided by ai. How much you are getting here? Let me know what is the value you are getting here. Let me know how much value you are getting there. Calculate very fast and tell me the value. 3.62. Right. 3.62. That is correct. So if you get this value of xi zi divided by ai as 3.62, now I can write very nicely. This q is equal to 0.1035 into 10 to the power minus 2 divided by density. How much? It is 8.18. We have calculated into 1 upon 3.62, isn't it? So that will be the q in terms of how much actually this q dash, if I write, this is actually q dash in terms of centimeter cube per ampere per second. So how much it is? Calculate and tell me the value. So dear students, if you calculate this q dash, it will be 0.35 into 10 to the power minus 4. Check it out. 0.35 into 10 to the power minus 4 centimeter cube per ampere per second. And if you want our real Q MRR in terms of the centimeter cube per second, so we have to multiply this Q dash by the flow of current, how much current you are passing through that circuit. Okay, so it will be 0.35 into 10 to the power minus 4 into current is how much? 1500. Yes, Kishore, that is correct. 1500 ampere. So tell me how much is Q? So Q you are getting as how much? And directly if I multiply here also with the 60, because per second, no, so in 1 minute there are the 60 seconds. So if I multiply by the 60, so definitely finally what they have asked, the value in centimeter cube per minute. Okay, centimeter cube per minute they have asked the thing. So directly if I multiply here with the 60 also, then I will get the answer directly in centimeter cube per minute. And how much it is? So see, I am getting the QMRR, it is 3.15 centimeter cube per minute. Check it out, check it out. Very nice, Kishore, very nice, excellent. So this is our value, this is our value, this is our last answer. This is the value they have asked, this is the value they have asked. I hope it's clear. अरे भाई किधर हो भाई, आ जाओ सब लोग. It is very useful here. 3.15, that is correct. Aman, only see Aman, Kishore and Akhilesh. Yes, take the next question. Shall we go for the next? Yes, 3.15, that is the correct answer. Next question. Okay, so this is the next question again on the ECM, dear students. In ECM operation with the flat surface, a 10-volt DC supply is used. The conductivity of the electrolyte is 0.2 ohm inverse centimeter inverse, and the field rate of 1 mm per minute is used. The workpiece is of pure iron. Workpiece जो है जिसके ऊपर आप ECM ऑपरेशन करने वाले हो, that is the pure iron. Calculate the equilibrium gap. So we need to calculate the distance between the say tool, electrode and the workpiece. Okay, so this is the equilibrium gap you want. Say YE is the equilibrium gap. Consider the tool over voltage is given as 1.5 volt, right? So gram atomic weight of the iron is given 55.85 grams, valence is given, and density of the iron is given to you. So dear students, if you know that there is a very standard formula, to calculate what? To calculate the equilibrium gap or the feed rate for the electrode. Definitely it is very easy. It is given by which equation? That is Y is equal to, or YE is equal to K into A into bracket V minus delta V divided by rho FZ into small f, where YE is what? Please keep this formula in mind. YE is equilibrium gap between the electrode and the workpiece. A is the gram atomic weight. K is the conductivity of electrolyte, which is the reciprocal of the resistivity, isn't it? Conductivity, okay, of electrolyte, which is in ohm inverse centimeter inverse. What is here? Rho, you know, density of the work material, density in grams per cc. Z is a valency of material, valency, okay, and F is what? Field rate, which is what? If you are using the CGS unit, generally use the CGS unit, it is centimeter per second. Where V is what? It is a supplied voltage or applied voltage, okay. And here students, whenever there is a over voltage is given, which is given as say delta V, which is equal to how much here? They have given over voltage is how much? 1.5 volt. Okay, so very easy. I have given you the formula, so just put the values there. Just put the values there. K is how much here? They have given K is equal to 0.2 ohm inverse centimeter inverse. They have given the feed rate, that is 1 mm per minute. So definitely I want in centimeter per second. So 0.1, that is nothing but 1.1 centimeter, which is equal to 1 mm, divided by 1 minute, that is 60. So it will be centimeter per second, isn't it? Applied voltage is say 10 volt or how much? 10 volt. Okay, supply voltage is 10 volt. And what is over voltage? It is given as 1.5 volt. Right? Gram atomic weight is given to you, density is given to you, and valency is given to you. See here, all the things are given to you. Now put the values there. You will get this YE is equal to K is how much? 0.2 into gram atomic weight 55.85 into 10 voltage supplied minus over voltage 1.5 volt. If it is not given, take it as 0. Okay, over voltage not given, take it as 0. Divided by density 7.8 grams per cc, F 96500 Faraday's constants, into valency how much? It is 2, no? 2 into rho Fz into feed rate is how much? 0.1 divided by 60. So tell me value of this equilibrium gap between this electrode, between these two electrodes, that is say cathode and anode. Tell me value of this YE equilibrium gap, which will be in how much? In centimeter. Definitely it will come in centimeter. Yes, tell me the value. So dear students, on Tuesday and Wednesday we are having the marathon series on the metal forming, including the sheet metal working and all. So please do join the sessions in the afternoon 2 to 4 p.m. 2 to 4 p.m. on the YouTube channel. Again, once again, Gradeup GATE YouTube channel, dear students. On the same channel we will be having the marathon for the metal forming. So it is how much? It is how much? Calculate the thing and tell me. Aman, how much it is? Kishore, how much it is? 0.037. So can I take? It is round up to 0.04 centimeter. Okay. So please check the options. So it is 0.04 centimeter is correct. Yes. Yes, 0.04 centimeter. That is absolutely correct. So we will take the nearest answer is what? Option B is the correct. Option B is the correct. 0.04. 0.037, or you can take it as 0.04 centimeter. B Bombay is the correct answer. B Bombay is the correct answer. Yes, Akhilesh, very good. So there are so many people who are not actually participating. Please, dear students, I am requesting you to please be the part of this all the things. Okay, I hope it is clear. So which is the formula that you have to keep it in mind? This formula for equilibrium gap. No doubt we can derive this equation. We can derive this. How it is come? This is actually given with the kinematics and dynamics of the ECM. From that we can derive this equation. Clear? Shall we go for the next? Now solve this question. Yes, solve this question. So see, dear students, say this is the workpiece. Okay, the surface of the workpiece. Say here is the workpiece like this. Okay, and under the microscope you can see here. So definitely you get some peak to valley distance or some irregularity on the surface. Okay, which is getting exaggerated here. Okay, so if you see here, the irregularities on the workpiece is around 8 microns. Okay, and on the workpiece or tool it is on the tool it is 8 microns, right? So workpiece it is 8 microns, or on the tool it is 5 microns, right? So the equilibrium gap, or you can say here the nominal gap we can have, that is this summation of this 8 plus 5, that will be the our equilibrium gap between this say tool and the workpiece. How to calculate? So whenever the irregularity is given like this, so you need to calculate first the equilibrium gap, which is nothing but the summation of these two irregularities, that is 8 plus 5 microns. So how much it is? 8 plus 5, it is 13 microns. So 13 micron means how much? It is 0.013 millimeter, multiply by if I 10 to the power minus 3, right? And if I want in centimeter, try to take in CGS, so it will be 0.0013 centimeter. Okay, so now rest of things are very clear, dear students. Conductivity is given, that is 0.2 per ohm per centimeter, that is ohm inverse centimeter inverse. Supply voltage is 12 volts. Okay, over voltage is given 1.5 volts. Now what is there? Simply K is there, and you have to use here. Okay, for the iron you have to choose the things which are given in the previous numerical, that is gram atomic weight 55.85. I will write here gram atomic weight 55.85. You have to take the valency as 2 and take the Faraday's constitution 996,500. You should know that, right? And density of the iron 7.86 grams per cc. If you take this data, definitely it is given to you, don't worry about this. And now tell me what will be the what they are asking. They are asking the feed rate. They are asking what? The feed rate. So if the work is of pure iron, okay, the largest possible feed rate they are asking, largest possible feed rate. Please calculate very fast and tell me the value. So options are in front of you. Yes, what are you getting here? Come on fast. You know that YE is equal to KA into bracket V minus delta V divided by rho FZ into this feed. Now feed need to calculate. So feed I will write here KA V minus delta V divided by rho FZ into this Y. K is how much? K is how much? 0.2. Yes, 0.2. Gram atomic weight 55.85 into supplied voltage is 12 volt minus over voltage 1.5 volt divided by density 7.8 into F 96500 into Z 2 into Y is how much? 0.0013. It is in centimeter per second. Sorry, it is only centimeter. Y, it is equilibrium gap. I need this F, I will get in terms of what? Centimeter per second. Don't forget, you will get the value in centimeter per second. Tell me what is the answer you are getting for this? How much is the answer? How much is the answer? Please let me know. 0. Very good, Achilles. 0.059. 0.059 centimeter per second. Okay, 0.059 centimeter per second. Okay, let us check the options. 0.059 centimeter per second. But here don't forget they have given the different units here. Definitely please check the units, cross check the units. So whether it is, see, 35.7 mm per second, it is not possible. Okay, yes Amandip, but check it out whether it is 35.7 mm per minute. Kishore, you have to check the option. You have to check the units. So whether it is multiple select question or not, please understand. If it is, then you have to check. So if I multiply to the 0.059, say with the 1 centimeter is 10 millimeter, so multiply by 10, and per minute I want to write, then if I multiply by 60, so how much it is? Please check it out. Please check it out. Yes, Parth, very good Parth. So D is also correct. In that case, D is also correct. D is also correct. No, if I want to write this feed rate in case of the millimeter per minute, yes, so D is also correct. So C, so be calm there, okay, calm there, and try to understand the other. If they are playing with the units, you should get that idea. Okay, in a multiple select, this is the way they can have the multiple options in terms of the multiple units. All right, I hope so. So here Bombay and Delhi, B and D are the correct options. So B and D are correct. Okay, very good. Take this value, take this question and solve this very fast. A researcher conducts ECM on the binary alloy which is having the density 8916 kgs per meter cube of copper, having atomic weight 63.57, valency 2, and the metal M which is having the atomic weight of the 58.71 and valency 3. Faraday's constant given as 96500 moles per coulombs per mole, and volumetric material mole rate is given as 40 millimeter cube per second at a current of 1200 ampere. The percentage of the metal M in the alloy is closest to. Yes, come on, solve this question, dear students, very fast. Come on, solve this question very fast. So there is a binary alloy. One is there is a copper and other element or metal M is there. So for that M we need to calculate the percentage. Please come on, dear students, solve it. So what we can write here, we know the Q dash, which is nothing but what, 0.1035 into 10 to the power minus 2 divided by this rho into 1 upon the summation I from 1 to 2. Here only 2 elements. Binary means though elements are there in this alloy. So Xi Zi divided by Ai. Isn't it? Yes or no? So please calculate. So here they have given the value of Q directly. So Q, when it will get Q, then Q dash multiply by this current. So it is given Q is how much? 40 mm cube per second. Okay, so definitely it will be 40 into 10 to the power minus 3. Okay, centimeter cube per second. And current is how much? It is 1200 ampere. Yes or no? 1200 ampere, no? Right. So I can write here this 40. Q is what? Q is 40 into 10 to the power minus 3 is equal to 0.1035 into 10 to the power minus 2 divided by density is how much for this alloy? It is 8.916 grams. It is kgs per mm cube, that is 8.916 grams per cc. So I will write 8.916 okay, into 1 upon summation of Xi Zi divided by Ai. So this term I will say, this is a capital X if I write here. Okay, into current is there, into current 1200 ampere, into 1200 ampere. Then tell me how much this X value, if I try to find out, X will be equal to 0.1035 into 10 to the power minus 2 divided by 8.196 into 1200 divided by 40 into 10 to the power minus 3. Tell me what is the value of this x. And you know this x is what? This is summation of this xi zi divided by I. There are only two elements. So it will be say x1 z1 divided by a1 plus x2 z2 divided by a2. Please check it out. So tell me how much it is. How much it is this x? So it is 0.1035 into 1200 into e to the power minus 2 divided by 40 e to the power minus 3 divided by 8.916. Is it 3.48? 3.78? Okay, 3.788. 3.78. Okay, now you can write here x1 is unknown. If I write this is 100 minus x2, that is because there is a binary na. So once suppose one composition is known, so definitely we will get the other as 100 minus the any known value. So it is a binary. Well, if you know one, definitely 100 minus that known value, it will get the composition of unknown element, isn't it? So into what is the valency for one, that is for say copper, they have given 2, valency as 2 divided by gram atomic weight. For that it is 63.57 for copper, and for material M it is x2 into valency is how much, 3 divided by gram atomic weight is how much, 58.7. it is equal to 3.78. okay, tell me the x2 value now. So x2, that is composition of em only, that is composition of em only. See the percentage of metal M, they are asking the x2, that is second composition, that is for metal M. Tell me so x2 here, tell me how much percent. Yes, come on. I hope by the aptitude, this is simply aptitude, you can calculate. Tell me what is the answer. Aman, Kishore, Akhilesh, Parth. Akhilesh Khadse, tell me the answer. Come on. So how much it is this x2 percentage? So it is binary alloy. Yes, x2 is how much? 32.7%. Very good, 32.7%. Let us check the options. Okay, 32 point around 6. Okay, so B, Bombay is the answer. I hope B correct. B is correct. And definitely remaining A will be how much? If I want for this percentage of copper, so it will be 100 minus say 32.58. So we will get left over the percentage of this copper. I hope everybody is getting this 32.7. Please check it out. अरे हाँ मिला कि नहीं भाई. It is composition of this alloy or metal M in this particular binary alloy. So how much time required? Only 2 persons are doing calculation till this much time required. I hope it is clear. I hope it is clear. I hope this question is clear. If you say the similar question in say GATE 2008 by the ISC Bangalore, so there was the metal P was there, and binary alloy was the known alloy was the alloy of the iron, isn't it? So take the next question. Take this next question. Take this question. Come on, dear students. Be active. Yes, in ECM, it's performed to remove the material from an iron, okay, surface of say 40 by 40 mm under the following conditions. Inter-electrode gap is there 0.02 centimeter, right? Supply voltage is there 15 volt, over voltage is there 1.5 volt. Specific resistance of electrode is given. So it will give you the conductivity because they are inversely proportional to each other, conductivity and resistivity that you know very well. Atomic weight of the iron is given 55.85 grams. Come on, jaldi fast. Valency of the iron is 2. Faraday's constant 96500. The material removal rate in grams per second they are asking, in grams per second. So definitely in grams per second there is a mass flow rate, isn't it, which is equal to AI divided by FZ. Yes or no? AI divided by FZ. This is a gram atomic. This is a mass flow rate in terms of the grams per second, right? M dot. So please, whenever the unit is grams per second, they are asking not for the MRR in centimeter cube per second. They are asking the mass flow rate in grams per second, right? So how I can write that? So for that, current is there. Current is not given there, isn't it? So in this question, dear students, the current is not given. But how much surface that you are going to machine? You are going to machine 40 by 40 mm surface. So that is 4 centimeter by 4 centimeter. I want all the things in terms of CGS. So ये पहली चीज याद रखना. You have to take it in CGS. Okay. Very nice, Kishore. Very nice. Excellent. So for that first I need to calculate the current. But current is not given. So definitely I can have the current density. Current density पहले निकाल सकते हैं हम. That is given by the J. J is equal to K into bracket V divided by equilibrium gap between the two electrodes YE. So K is how much here? It is 2.2. It is specific resistivity. Definitely it will be 1 upon 2.2. That will be the K. Supplied voltage is 15 volt. Over voltage is 1.5 volt divided by equilibrium gap is how much? 0.02 centimeter. Tell me what is the current density? So you will get the current density here how much? If you calculate this, you will get 306.81. This will be ampere per centimeter square. This is the current density J you will be getting. But here if you want the current, so current I will be the current density into the area. So J is how much? It is 306.81. And what is area of the surface? It is 4 by 4 centimeter square, isn't it? So it will be 16. So how much is the current? 4909 ampere. That will be the current requirement, that particular process, this particular process. And once you get this current, it's very nice to calculate. M dot is equal to AI divided by FZ. So a gram atomic weight is how much? Iron 55.85. Current is how much now? 4909 divided by Faraday's constant 96500 into valency 2. So tell me the M dot. I am getting as 1.42 grams per second. I hope it is clear. So very easy question we have in 2009 ME paper like this. Yes or no? 2009 paper. अरे भाई आया कि नहीं आया? जल्दी से बताओ. Let me know whether are you getting or not. See the basic assumption. I told you in the first class also. I am repeating that. I am assuming that you are knowing something about these particular topics which I am discussing. Okay, so we are going like this: formula, numerical, answer. Formula, problems, put the use of that, or use of that formula in that particular numerical, and calculate the things. I will give you each and every formula in case of the ECM and EDM today, so that any question if you get, you should not stuck. Yes, Amand is 1.42, 1.42. Akhilesh time lag raha hai bahut bhai. Aman is so fast. Sorry, Kishore is so fast. Nice Kishore, very good Kishore. खडसे साहेब वेळ लागायला लागलाय. So next question. Okay. So see, this is the question based upon what? The EDM. Now we will start. So ECM both हो गया भाई. Now let us start some EDM questions we will solve here. Okay, take the EDM question. So before that, just understand, dear students, the EDM. So we are having here supply voltage. Supply voltage. Then who will tell me? Khadse. Supply voltage, you are having the discharge voltage. Okay, right? So here, dear students, there are the times. Cycle time is there for the charging and for the sparking. Okay, but generally say sparking time is very less compared to the charging time. So here in the EDM process, you will get this cycle time TC. Okay, is equal to what? सबसे पहले तो क्या आता है वहां पे? The energy required or energy released per spark. If I calculate first, I will write here energy released per spark, which is given as half into this capacitance C into discharge voltage square. Okay, so this is the energy released per spark in terms of joule you will get, and here the time, cycle time you will get, that is R into C ln of VO divided by VO minus VD, right? Where R is the resistance, C is the capacitance, which because you know we are using the RC, resistance, capacitance, relaxation circuit, right? Ln of supply voltage VO divided by VO minus VD. So this is TC. So this is cycle time for charging. If they have given the TS, the sparking time also, then you can add here this cycle time for the charging plus cycle time for the sparking. All over you can get the total time. To calculate the power, how to calculate power? That is nothing but energy divided by the cycle time for the charging plus cycle time for the sparking. You can get this power in terms of watt, or generally you can put in terms of kilowatt, right? And finally from that, this material removal rate in case of EDM, you can write in terms of, say, this power, that is 27 point, I hope it is given here in the question, 27.4, okay, into this power P or W to the power this 1.54. And please remember this power W, it should be in kilowatt. It should be in kilowatt. This is the average power, should be in kilowatt. Please see, if you have knowledge of this formula only, that is more than enough. Okay, at this moment, if you have the knowledge of this formulas related to this electro discharge machining, right, that is more than enough. You can able to solve the question. Okay, and many times what they will ask, what is the time required to do the operation. So once you get from the geometry of the machine surface, so if you get the volume of the volume removal, okay, and if you know the material removal rate, rate means per unit time, so definitely we'll get the time required to do the operation. Time required can be calculated as the volume, okay, to be get removed divided by the removal rate, that is say volume per unit of time, volume removed per unit of time, and definitely will get time here. Okay, So like this you can able to calculate the things for this particular EDM process. Now what is given in the EDM process? So there is a drilling with the EDM 10 mm square hole. So square hole, this is of 10 mm side. And what is thickness of this plate? So if I say here thickness of the plate is how much? It is 5 mm. So what is the volume we are going to remove from the plate? If say plate is like this, okay, so this is a square hole of 10 and thickness is how much? Thickness is 5 mm. So how much removal that we have from that plate? Material removal is how much from that plate? So it will be say 10 square into 5. So it is 500 mm cube. How much this volume of material you are going to remove from this, right? Now what they are saying, using the brass tool kerosene as the dielectric they are going to use there to increase the efficiency of the melting zone, right? The resistance and capacitance in the relaxation circuit, resistance is given as, resistance R is 50 ohm and capacitance C is 10 microfarad, that is 10 into 10 to the power minus 6 farad respectively. Supply voltage VO is given as 200 volt and the discharge, so discharge, that is sparking, takes place at 150 volts. 150 volts. Estimate the time required to complete the drilling operation. And what they are saying, the MRRQ can be approximated or expressed as Q is equal to 27.5 into W to the power 1.54, where W is the average power. You should take it in kilowatts, please don't forget this. Okay, so very nicely, you know power is what? First of all, energy divided by time. So calculate the energy first. So how will calculate energy? You know energy is equal to, so if I will write here half into C into discharge voltage square, half into capacitance is how much? 20 microfarad, isn't it? 20 given, no? Okay, sorry, 10 is given. So how much it is given? Is it given as 10? Okay, so 10 this 10 into 10 to the power minus 6 into discharge voltage 150 square. Okay, so tell me how much energy? How much energy? अरे भाई बताओ जरा बताओ. 10 e to the power minus 6 into 150 square divided by 2. It is 0.1125, or I will take nearly, I rounded to 0.113 joules. This is the energy. Okay, release per spark. This is energy released per spark. Okay, I hope it is clear, Akhilesh. Now see what they are asking. First of all, we need to calculate this time for charging the capacitors. Okay, charging time. Very good, Akhilesh. 0.1125. I have rounded to 0.113. That is okay, no issue. It is given as RC ln of, or natural log of, VO divided by VO minus VD. And how this equation come, you know very well, we can derive it. Okay, I can write here. So TC is equal to, what is resistance? 50 ohm into excellent Kishore, excellent. So into how much that capacitance? It is 10 micro ohm, 10 into 10 to the power minus 6 into ln of the supply voltage 200 divided by 200 minus or discharge voltage 150. Tell me what is this charging time? If you get around 7 into 10 to the power minus 4 second. Okay, nothing is mentioned for the sparking time, so neglect it. Now tell me what is the average power? That is energy release per spark divided by this TC plus TS. Okay, TC TS know anything, you calculate it, just eliminate it. E divided by TC. Energy is how much? Energy 0.113 divided by charging time 7 into 10 to the power minus 4. Okay, second. So tell me how much it is? Joule per second. Joule per second. Joule per second is nothing but the watts. So tell me how much watt average power, say P is equal to how much you are getting? whether you are getting 0.16 kilowatt. Check it out. And when you get this power at 0.16 kilowatt, you know that this Q can be nearly or approximately equal to 27.4 into this, say, P or W to the power 1.54, where P should be in what? It should be in kilowatt. Don't forget it. You will get answer in mm cube per minute. Okay, very good Kishore. Now if I write here this Q material removal rate, if I want, this is 27.4 into power is how much in kilowatt? 0.16, that we have got to the power 1.54, isn't it? Tell me how much is Q? How much is Q? बताओ material removal rate कितना है? Rate is it 1.633 millimeter cube per minute? So you have got here the material removal rate, right? And when you get this material removal rate, I told you the time required for doing the operation, time required to do the operation, this EDM operation. How will write? This volume divided by volume removal rate, material removal rate. So volume is how much? 500 divided by this Q is how much? 1.633, isn't it? Okay, tell me how much it is. So 500 divided by 1.633, so will it be 306 minute? So this is the time you require to drill that hole, which is square of 10 mm and thickness is what? 5 mm of that plate. I hope it is clear. So okay, 300, around 300 minute. Okay, chalo 300 minute. I hope it is clear. So dear students, I hope, see, on the non-traditional machining, particularly on ECM and EDM, we have talked a lot. Okay, I want to again talk for this non-traditional machining. Take this question as homework. Again, same question based on the previous one. Okay, see, this is actually GATE question. This is question from the production and industrial engineering, PI. Okay, like same, they have asked this question for 4 marks, 2 marks here for the time calculation. Okay, TC, and 2 mark for the power calculation. Very easy. After this, actually I want to start with this. These are the very simple theoretical questions that we have. Okay, you can definitely do this, and I have not mentioned there whether it is MCQ or MSQ. You have to see it very carefully and answer it. Now these are the questions related to the this is the NCCNC, okay, based on the drives, right? Advanced machining methods. So I try to take one more session separately, which is on the CIMS. Okay, please understand, and we will definitely separately see this advanced machining methods, right? Is it okay, or shall I take this 1 or 2 numericals right now? So we will plan it for one more session regarding to this advanced machining methods. Okay, these are the questions, some of the questions we are having for the CIMS. Like suppose if I take this question, okay, if I take this question, अरे कोई तो रिप्लाई दो भाई, कुछ तो बोलो, क्या करूं? So is that okay for the today's session? Tell me something, Akhilesh, Kishore, Aman. Say for example, here they are asking the positioning accuracy of that NC machine, okay, which is nothing but plus or minus 1 pulse of the stepper motor, yes, isn't it? And yes, which can be very nicely calculated as what they are saying. In a point-to-point control NC machine, the slides are positioned by the integrally mounted stepper motor drive with the specification of the. Okay, we'll take this question. Indra Kumar Dhawale Sahib. Okay, we'll take this question and definitely we will discuss again all these questions. Still one more session we require to complete this CIMS also. But tomorrow, in the tomorrow's session, dear students, I will be taking metrology and inspection. The questions from these. Okay, we'll try to focus the area where we can expect the question. Okay, not like that each and every topic I will be covering. So within 1.5 hours it is not possible, but we'll try to get the we'll try to choose the areas where we can have the certainty, right? Take theory questions. Okay, let us solve this question, or we will take, of course, afterwards take the theory question and tell me the answer. Okay, tell me the answer for this question. Consider the following statements. The electrolyte is used in the ECM. Yes, electrolyte is used in the ECM. Okay, it can be chosen such that the anode can be dissolved, but there should not be any deposition on the cathode. So it should be flushed out, and it is flushed out by, it is again carrying away by the small chips and all by the electrolyte. It will passing the huge amount of current. It will complete the circuit. You know, all these are the properties of the electrolyte. Yes, electrolyte is used in the ECM. That is correct. So electrolyte is not used in the EDM. Okay. There is a dielectric fluid. There is a dielectric fluid is there, where within that dielectric fluid entire the setup is immersed. In case of EDM, abrasive slurry is used in the USM. Yes, abrasive slurry generally it is abrasive which is mixed with generally water. In case of the USM, again we are having some other liquids also used as a liquid element in case of the abrasive slurry. But yes, abrasive slurry used in the USM, that is correct. Abrasive slurry is not used in the AGM. In abrasive jet machining, we are having the abrasive either mixed with the air, or CO2. That you know, air or CO2. So slurry is not there. So abrasive is mixed with the moving with the high speed air or CO2. So yes, P and R are the correct statement. P and R. A Ahmedabad, very good. A Ahmedabad is the correct answer. Yes, Kishore, 10 micron, that is correct for that question. The positional accuracy, excellent. Yes, Dhawale, very good. Dhawale, welcome to the Gradeup. Very nice name, Indra Kumar. Okay, so A Ahmedabad is the correct answer. Very good, very good. Take the next question. Which one of the following statement is true for the USM process? Or statement or statements, please check it out. In USM, too low vibrates at a subsonic. No, it is a ultrasonic frequency is there, right? USM employ magnetic transducers. Yes, transducers are there to have the movement of the tool, okay, to vibrate. Yes, magnetostrictive transducers are there. USM is excellent process for the brittle materials. Yes, it is very useful for the brittle materials like glasses, like ceramics. Okay, we can drill the hole in that, right? Absolutely correct. USM is excellent process for the brittle material. Yes, USM often uses the slurry compressing abrasive particle and water. Yes, this is also absolutely correct. B is also correct. Yes, Akhilesh, tell me then what is the correct answer? Yes, there is a magnetostrictive transducers are there. They are excellent process for brittle material. This is also correct statement. And it is using the slurry with the water, abrasive particles mixed with the water. That is also correct. Yes or no? But as the viscosity of the slurry increases, okay, viscosity of the slurry increases, this is a Q, go on decreasing. That you know about USM. This is the viscosity of slurry. This is the MRR. So what is the correct answer? What is the correct answer? So B, C, D are the correct. B, C, D. Bombay, Chandigarh and Delhi. Very good. So dear students, I will wind up this session here with the last question. Which one of the following process condition leads to the higher MRR in the ECM? higher MRR they are saying. So higher MRR is what? Q is equal to AI divided by rho Fz. So higher current, yes, higher current is there. Lower atomic weight, not correct. Lower current, not correct. Higher atomic weight, yes. Higher gram atomic weight, yes. So A and D here are correct. A and D are correct. I hope it is clear. Akhilesh, Indra Kumar. So dear students, on these notes, definitely I will try to have one more session on for the CIMS. Yes, Ahmedabad and Delhi are correct. A and D are correct. A and D are correct. A, B, where is B? Lower the atomic weight? No. Gram atomic weight also higher, then you will get the higher MRR, directly proportional. Okay. The most common interpolation methods used in the continuous path NC machining, dear students. So there are the linear interpolation, circular there, elliptical there, parabolic there. But amongst all these interpolations, dear students, we are very highly using the linear and circular interpolations. So A and C are correct. A and C are correct. In case of this continuous, the interpolation method or methods in continuous path NC machining. So yes, we are using the linear and circular interpolation. Most common. Which one of the following statements are correct for the CNC toolings? So toolings must be rigid. Yes, that is the very important condition criteria for the tooling which are used in the CNC. The tooling should be capable of preset and reset. That is also very important property or the condition. It can be preset in the tooling laboratory, and directly during the setup comes, they can directly take the fixtures or whatever the holding devices or whatever you have made that fixture, you just take and go and arrange onto the machine directly. So preset, reset is available. Yes, that is very correct. The tooling should be capable of preset and reset. That is also correct. Tooling should be accurate. Yes, no doubt the tooling should be accurate. Preset and qualified tools are used for the CNC. Yes, this is also correct. Preset and qualified tools. So if you right now there is no time to discuss, but yes, in the CIMS I will definitely go in details about the toolings for the CNC. So all the statements are very correct. All the statements A, B, C, D. Okay, Ahmedabad, Bombay, Chennai, Delhi, all are correct. Very good. Tell me, in point to point type NC system, point to point, you know that is the starting and ending points are very important. Whatever the path followed the tool is not important. Okay, start and end is very important, irrespective of how much path this traveled. Okay, say this is one point here and this is point here. I can come like this, I can come like this, or I can come like this. So the path followed by the tool is not important, but starting and ending positions are very important. So tell me, so control of only position is sufficient. Yes, B, Bombay is the correct answer. So I hope in point to point, B, Bombay is correct. B, Bombay is correct. Very good. So for this question, dear students, see what they are saying. If the specification of the motor, what motor is specified 1 degree required for 1 pulse. Okay, so definitely if I take 360 degrees, so I will require 360 pulses. Okay, and you know that 360 degree means what? 1 revolution of that motor shaft. Okay, so it will be 360 pulses. But you know, when the motor is revolved by 1 revolution, rotate by 1 revolution, the lead screw will have 1 rotation, which will be having the linear displacement of equal to 1 pitch. So 1 revolution is equal to 1 pitch. It will be having with the 360 pulses, isn't it? So what is the pitch of the lead screw given here? 3.6 millimeter is the pitch of lead screw. It is 360 pulses. And you know that, dear students, the accuracy or the positional resolution is nothing but plus or minus 1 pulse. You know very well, either with the excessive energy it is positive, or with loss of energy it is a negative pulse. So yes, so tell me what is the value of 1 pulse here. So 1 pulse is equal to, that is 3.6 divided by 360, which will be 0.010 millimeter, which will be 10 microns, I hope this is also clear. So what is the answer here? So B again, B Bombay 10 microns. Right, so like that you are having many types categories to solve the questions on these CIMS, right? So I will wind up this session right here, okay, and take this as a homework, or you know this answer for this. The function of the interpolator, that is nothing but what? It coordinates the feed rates of the axis, okay. Feed rate interpolation means that you know very well. So thank you so much, dear students. Thank you so much for joining the today's session. Be there in the large number, dear students. These are very helpful things for you. Definitely these, whatever the things we have discussed since from the first class, first session, these are all very beneficial to you guys, okay. So please share this information among your friends. Ask them to join these sessions, right? Tomorrow metrology and inspection, right? And on Tuesday and Wednesday we'll be having the YouTube sessions for 2 hours, all the things related to the metal forming, right? Metal forming. So do join me on the Gradeup app. There are also the very nice series are going on. Join there, and you can see here the courses launched by the Gradeup Super, dear students. Again I am telling you, please, if you are right now in the second or third year, go through this details for the Vision 2022. Excellent course, a very ideal course for the second and third year engineering students. Any information that you want, any query that you have, contact on this given number. These are our star faculties from the Gradeup: Dheeraj sir, Rushi sir, Ankit sir, myself is there, Chandra sir, Harshit sir, Balaji sir, right? These are our achievers. This is the pricing. For any details, just contact the given number. All the queries get resolved there. So yes, tomorrow once again we will be meeting at 7 p.m. The topic will be metrology, related to metrology, and share this information. Dear students, please share this information among your groups, okay, social media platforms, so that the many number of students get benefited. Thank you so much, dear students. Bye bye, take care, good night, Jai Hind.